Okay, so we'll go ahead and get this started. Just want to introduce myself really quick and then introduce our friends from Dell. So KJ Burke, I am the architect manager for hybrid cloud for Eastern Canada for CDW. And so my focus is around the hybrid cloud and the story that we tell within the hybrid cloud to help our customers solve their challenges and build business value. And then from Dell, we have a couple of people. Very excited to get you in touch with them. So Valerie Harrison, if you could introduce yourself.
Hi, thank you. Yes, I'm Valerie Harrison. I'm a corporate advisory engineer here at Dell. I work in the unstructured data division, and so I come to the AI world through the lens of unstructured data and also from infrastructure. I come from infrastructure background, and I do a lot of talking to customers who are in IT around architecting for AI to meet business needs.
Great, thanks, Valerie. And then Anthony Dina, if you could please introduce
Hi,
yourself.
Yeah, of course. Anthony Dina here, Director of AI and Research Computing. Our team of experts are focused in North America to help customers go from that first use case to production and into large-scale operations. Very excited to join this conversation with CDW and my other peers from the Dell team.
Great. So, one of the things I'm excited about, and I've said this, to the team that I work with, is every time I've had a chance to talk to Valerie and talk to yourself, Anthony, I learn things. So I just want to get right into the conversation. When we look at AI, we look at how science fiction has presented AI. It's things like the Terminator, or it's things like Westworld, and it really is this sort of autonomous decision making construct. When we look at AI and what AI is currently doing in our everydays in business, I'll put this out to you, Anthony. How are we seeing that, and really what does practical AI look like?
Well, interesting you should ask that, because AI has been coming along quite nicely without anyone really paying attention. The minute you talked into your phone and addressed Siri, or you looked at that little puck on your desk and asked Alexa for something, you were actually engaging in an interface that was simulating your conversation into text that a computer could understand, search the answer, respond, and then translate that back. So one of the very interesting pragmatic exercises is a human to machine interface. Now, we do this more frequently now with chatbots. So as you're trying to resolve an issue, or maybe you're trying to find out what's going on with a certain celebrity, you can actually connect with those individuals through a computer-generated device. But I think the most interesting aspects to artificial intelligence comes when the computer is enabling the decision rather than replacing the human. And the reason why this is extremely exciting is because up until just a few years ago, computers were very flat. They looked at rows and columns. It was very two-dimensional. And we as human beings are built from a very interesting computer in between our ears, and it's our eyes, ears, our nose, our mouth, and our hands that can determine temperature and vibration that enrich data that we might originally get. And now the computers are starting to access that. So we can have better incorporated decision making when we can take more of the senses in the environment and really drive those kind of outcomes.
Yeah, so I like that, and the idea of AI-enabled decision making. So Valerie, when you think of AI, enabled decision making, how does that impact the businesses that you work with?
Yeah, sure. I mean, I think Anthony makes a really good point that AI helps enrich what we're trying to do. It will not replace what we're trying to do. It really needs human supervision. It leans heavily upon us helping it, supervising that learning and things like that. And so companies are really looking to have AI assist them with decision making, whether it be customer loyalty, whether it be the natural language processing that we talked about, or even driving efficiency. I have a customer who has plant floor manufacturing systems, and they're trying to drive efficiency on the plant line and making decisions in real time with weights that humans put in there around using less product on the line and making those decisions in real time. There's just too much data for any human to look at every piece of data that's coming in from every machine, every sensor, in their environment. So we rely on machines to process it, and then we help them make good decisions that can feed back into that system.
So it's not an autonomous Skynet that we're talking about. We're really talking about. Okay, so okay, well, I
No
can
Terminator.
sleep a little better tonight then. So so then when we if we look at AI and we look at what companies are doing with it, we're trying to make better decisions. You know, what's the drive for AI right now, Anthony? When you start to look at the business drivers in our current state, what are you seeing customers say?
Yeah, so a large number of the most interesting use cases have originated from what I call web tech companies. Companies that have looked at the way we bought books online and changed that process irrevocably for being able to select an item, understand its price, and receive it in the mail, sometimes as little as 24 hours. And this chewing at the way we do business and the way we handle it is called the digital enterprise or digital lifestyle. Recent conditions with COVID and the pandemic, which has now separated us physically in order to be physiologically safe, are now putting increased pressures to be able to provide telemedicine, as an example. So the doctors who don't want to infect their patients or in fact become a cause or be taken out of the system are now forced into a new way of interchanging with their customers. Likewise, if you have a manufacturing site and you have a large number of workers that are coming inside of that facility, it's incumbent upon you to maintain that level of safety and distance, understand in a quick sense whether they might have an excursion temperature and maybe need to be pulled aside. So we're looking at how do we get together safely in environments when we do get together, and it's the computer-aided video or video as a sensor, if you will, is that it's going to allow us to get through that. So I see not only just the general trend towards this transformation of digital services, but now with the economic and pandemic concerns, it only gets even more heightened. In fact, Mary Meeker, who famously published her first report in 1995 on the internet, issued a new edition just last year, but she focused on COVID and its major effects in April of this year. And what she said was, interestingly enough, that tens of billions of dollars of venture capital have gone into darling companies like Uber and Lyft, and their revenues have taken quite a hit in this time. And other companies like DoorDash and other delivery services are on the meteoric rise. So our assumptions about what is true and natural of how we're going to do things can be radically shifted like a light switch. And that's where I think if you take the right amount of algorithms, a good data set, and some business process, and you're focusing on outcomes for your customer and for your business, you can really make a huge difference.
Okay, yeah, and I think you talked about that light switch effect, and you talked about how we're kind of in a period of change here, and I think what Valerie was talking about as well, where the more data feeds you have, then again you can make better informed decisions. So Valerie, when you look at digital transformation and you look at the pressures that businesses are under, how do you see AI and how do you see the impact of AI on business decision making, helping businesses as they go forward?
Yeah, sure. I think it's interesting because, we here at Dell have talked a lot about digital transformation, and part of that journey is to drive efficiency and savings and infrastructure to be able to fund projects that drive the business forward. So AI is definitely one of those projects that they are focusing on, that businesses are focusing on to try to get that competitive edge. I think that, every vertical, every segment is looking at AI to drive efficiency, my manufacturing plant example, to make better decisions. I work with retail companies who are looking to drive customer loyalty and using AI in really, really creative ways to try to drive customer loyalty and to get people to sign up for rewards programs, and then just to help them make better decisions. So with regards to, Dell in particular, we have data scientists here. We definitely drink our own champagne, if you will, and use AI to take the vast amounts of data that we're getting from things like parts repair, so logs and sensor data and things like that, to drive better efficiencies with logistics. So, and when a part comes in, we know what to do with it, what's wrong with it, and then also predictive failures. So understanding where things fail, maybe before the part even knows it's going to fail, by understanding all the data that's come off the parts before them. So I think it's definitely something that we're trying to get companies to fund to look a little differently, because every single vertical, every single company can benefit by an AI objective.
Okay, and then
let me just kind of jump right on top of Allie, because she's absolutely right. But what's interesting about our own predictive analytics, where we were trying to determine whether a hard drive was going to fail on a laptop or not, we didn't start with some fancy neural network. We started with some really basic linear regressions. And we slowly moved into that direction when we understood that the kind of data was choppy, lumpy, and incomplete. And so we kind of grew our way into that as we get deeper and deeper into those use cases, and we needed a way to normalize that data. And that's where this is where we see a lot of success, where people start with really basic questions like a linear regression, and then they move past very simple correlative analytics and start asking deeper questions, which involve other algorithms, which involves other data. And then this kind of snowballs into some really sophisticated and very interesting outcomes.
And that's interesting, because again, when we talk about AI, there's a bunch of different things that make up AI, and we don't want to slideware everybody, but there was a couple of visuals that we wanted to show throughout the conversation. So I'm going to go ahead and put this visual up, and maybe Anthony, you can speak a bit to this as a concept. And so when you're talking about going from one type of data and one type of learning into a different type of data and a different type of learning, how does that relate to, really artificial intelligence as a whole and the different subsets?
Yeah, let's break this down. And there's a couple different philosophies around this. So somebody would even describe data science as a bigger bubble. And really, this is really trying to translate real world problems into some kind of math, some kind of algorithm in which to apply for that answer. Now, artificial intelligence is called that because it's trying to emulate the human intelligence by looking at certain key input variables and then determining an output variable. The machine learning or machine learning aspect, that second bubble, was really meant to describe more statistic-like modeling. So you might have boosted tree algorithms or Bayesian, and this family of math, if you will, is not uncommon. What becomes uncommon is when we start changing the data type and we start throwing in images, and we start throwing in sound, and we start throwing in temperature. Now, all of a sudden, we need to emulate the way the human brain works through its neural networks, and that's why we get to artificial neural networks, and that's why deep learning is considered a subset of the overall ML.
Okay, and then, and so, my understanding, and Valerie, you can correct me if I'm wrong, is that really if you're to do different things, you're going to be modeling things differently. So by packaging all of those under AI and having different types of math to associate with those problems, it's really a lot about deciding what is the best tool for the best job. So how do you approach those different areas with different tooling?
Oh, is that a question for me?
Sorry, yes.
Yeah. Well, I think to Anthony's point, you don't have to start at the neural network. You don't have to start at all the buzzwords. I'm gonna approach a problem with TensorFlow. I'm gonna get the best toolkit out there. I think there's a lot of problems that can be solved very simply. Some machine learning can be done in Excel. It's very statistics driven. And so I think understanding the nature of your problem And starting somewhere and starting small to look at your data and even just to define the scope of the problem can inform you where you need to go and where you need to leverage other tools. It doesn't have to be, you don't have to hire a data scientist day one. Understand the scope of the problem and start small. Start where you can get some good data out of it.
Absolutely. And so, so I have another visual I'm going to bring up. And so for Valerie, now again, we talked about this, and in Canada, it's more of a moose on the table, but I'm going to put this one out to you. So what does this make you think of?
It's the elephant in the room, or the elephant in the data center, more like. I really like this. I stole this from a friend of mine at NVIDIA. He talks about, there are elephants in the room when you talk about AI. People want to jump to the algorithm, or they want to jump to, like, I'm going to buy a ton of GPUs and I'm going to solve this problem. And the elephant in the room really is scale. I mean, there's a lot, we could go into the weeds around infrastructure, solutioning, but really it's around the scale, and it's the amount of data. It's the data gravity. So the fact that you're creating so much data, applications are attracted to the data, and you can't move it very easily. It has to stay in place. You're not going to move petabytes of data if that's the data set that you're analyzing. And that can really impact infrastructure. It may not be possible in the cloud at scale if you're trying to solve complex problems. I've been working with a research university in the Midwest, and they are trying to map the active neurons in the brain of rodents. They're going off of the Allen brain study of Drosophila, which is the fruit fly, and they are looking to solve the problem of how do we map active neurons in the brains of humans. But you have to start somewhere. Started with, oh, thank you for the picture. Start with the fruit fly, go to the mouse, move to the human. Mouse brain, they're looking at 44 petabytes of data to map all of those active neurons. There's not enough PhDs on the planet to go through every picture and say, is that a fuzzy picture, is that a good picture, stitch them all together. They need to use machine learning to do that. And the data at scale is very large. How do they get it to the data center to do that munging? Human brain, they're talking hundreds of exabytes of data to start mapping the human brain. So the elephant really is in the room is, where are you creating your data? What are you trying to do with it? And how do you get your applications to your data? These are things that you need to think about, because really more data is better for analytics accuracy. You need more data. And that's the big message there.
Yeah, and so I guess, sort of the same question to you, Anthony. When you look at the barriers that the companies are going to have in place to, really take their data, the data science practice to the next level, what types of barriers are you seeing customers, hit, and how are they sort of getting through those?
Yeah, so I mean, Vala makes a fantastic point about data gravity, the data aggregation, the size of data, and the scale. But the good news is a lot of the tech has really grown up and be able to process and get to results in measures of hours or minutes. And we've got tremendous amount of performance characterization that we've done with accelerators, without accelerators, with all flash. We've kind of done our homework on the real basic thing. But yes, pumping this through where big data meets big compute. That's my view of AI. We've done that work. But the other thing that becomes really important in this process is really getting down to the use case. The use case determines what data you want to use, and then that data determines what algorithms that you want to choose. And we call this our AI hierarchy of needs. So just like Abraham Maslow did in the 30s of the last century, describing that the human condition must be satisfied in tiers, starting from the physiological up through the philosophical, we believe that artificial intelligence begins with the use case. The data comes second. You may not need a lot, but you need to know what you're working on. The algorithms and software are on top of that. And the last possible decision you need to make is what hardware to buy. Because until you know everything else, it's irrelevant. So we look at really trying to understanding a crisp, clearly defined outcome of what we're trying to get accomplished, and try to align what's both feasible, meaning like I've got that data and I can get access to it and it's relatively clean, and then business impact. Will it make a difference if I can go figure this thing out? And when those two things line, highly feasible and high impact, that's the fertile ground on which you should go plant your seeds for AI.
No, that's really interesting, and it's also good to have like my Psych 101 course come to fruition in a technical role. So that's a good one. And I agree fully with the idea of starting with business challenges and starting with business objectives, and really sort of drilling down to the technologies after the fact. But clearly defining that scope is important. And then one of the other areas that you both have talked to me about is really around, what are the implications to the organization? So obviously there's an implication. The elephant in the room is the data and the gravity of the data and how we get access to that data, and is the data clean? And what are our business objectives? But then AI is also, it has implications for your organization, how you're going to set up the processes, how you're going to set up the people. So Anthony, when you look at the implications of to an organization, how is that manifesting? How are our customers that are succeeding with their AI practice? How are they starting, and what does that grow to?
Well, I can tell you, let me just start with this very simple metaphor. I remember going to an automotive shop to get my oil changed in my vehicle, and right behind the service managers was a sign that said, "Customer service is not a department." And I look at the way we are driving these, what I call computer-aided decisions into the organizations as not a separate department. There's not some data science group or some cultural club that we'll give all the problems to. It has to become part of our culture. And to be part of our culture requires that there is domain knowledge from everybody that's built into the process. So when I look at successful organizations that have deployed this, they might create a core team that has the math-oriented people, but also people that are closest to their customer, internal or external. And then IT has to have a seat at the table, because this is where things get feasible. If you don't have, for example, the right amount of transit outside of a remote location because you didn't have the DSL connection or maybe the high speed or dark fiber, you're not going to be able to pump all of that video footage off a manufacturing floor. So you got to really think about all of those things at once.
And then so the same type of question for you, Valerie. Within an organization, when you see the new roles, whether it's a data scientist, how are organizations changing to support these AI practices as they're sort of blossoming?
Yeah, and Anthony makes a really good point. It's not a department. I just read, actually not like this today, I just read a report that did a survey of CEOs and companies that are looking at AI. And they said 71% of the respondents said that their company's AI projects were owned by C-level executives, whether it's a CEO, chief financial officer, or CTO. So this has to be owned and championed at the top. It has to involve business unit owners, because they're either going to own the data or they're going to be the internal customer of the data. And then, of course, the smart people, the data scientists who are, they really are becoming one of the most valued IT people, probably the most highly paid outside the CEO. They're very high in demand, and they change jobs a lot. They tend to be, some people say they're very unhappy people, because they don't often see their projects go into production. There's a lot of other things that they do. So there's that picture. They're the rock stars of the data center. Everyone's like, oh, that's data scientists. They're the hot commodity. But they're really trying to solve problems. They want to do data science. And there's a lot of things that they're doing that are not data science because IT maybe doesn't have the skill set or doesn't have the time to do the things that they need to do. Data scientists should be working on wrangling data sets and testing algorithms and tuning neural networks. They tend to do a lot of things like interoperability testing and deployment of frameworks and things like that they maybe shouldn't be doing. And maybe that's an opportunity for IT to step in and say, we have core competency in things like testing, this patch with this version of code. Maybe that's where IT can step in and help these people.
Gotcha. Yeah,
I want to point out something else, that a point Valerie made earlier at the top of the call that cannot be overlooked. And that is, she was talking about decision making in situ at the moment of. So you're getting a check engine light on the manufacturing floor or in the patient's office or on the telephone pole, wherever you're doing your task. And to do this, you really have to understand there's a third rail. And the third rail is how are the applications being designed? Because a lot of business processes involve an application. I fill out a trouble ticket. I respond to a trouble ticket, or I'm filling out an order. I may be talking to someone in a call center, or as a call center professional, in interviewing the problem and keystroking in the description of what's happening. And quite honestly, there may be a recommendation engine based on the word selection of the person on what to go do next. So application design and rolling this into the business process is a third aspect. And again, back to Valerie's great point, it's going to happen in real time. We can't wait to the end of the month. Even the end of the week is not tenable. In order for this to be successful, it has to be done as it happens.
Yeah, and it's interesting that you say that, because when I think of sort of the, we were talking a little bit about the current state of affairs, and with COVID-19 being out there, the number one comment around COVID-19 and testing was, we can't have a test that takes 3 days to get results. We have to have a test that gives us results as soon as possible. It has to be 15 minutes or an hour. And you're right. I think when you're looking at how much an impact a failure or a part breaking down on a manufacturing line, how much that impacts you, the faster that you know about it, you can do preventive maintenance, the faster that you can avert issues and keep them from becoming a drain on your company is obviously key. So we've got this challenge of all of this data. We've got data feeds that are coming in. We're trying to make decisions faster. Where can AI help, and what can we do to help our AI systems get access to that data? I guess, if we look at IoT and we're trying to collect data from sensors, trying to collect data from, maybe we've got data lakes, we've got different systems that are feeding in here. How are our customers succeeding in getting access to that data and still turning around, decisions or information faster for the customer, for their business? Sorry, Valerie. And I think I rambled there for a second. Sorry. So hopefully that makes sense.
It's all good. No, it's all good. I mean, I'm going to bring it back to, we keep going back to my plant floor systems customer. For them, and literally for that research university too, for them, it's about data movement. Sometimes it's about the amount of data, with regards to the cryon light sheet microscopes looking at active neurons. That's the scale of data. How do they do data movement? And so thinking about the network and thinking about where the compute has to happen. You can't necessarily do big compute at the edge, but the microscopes are at the edge. So data movement's huge. The plant floor manufacturing system customer, it's speed. They don't have time, again, to Anthony's point, they don't have time for it to go back to, the home office, for them to munge on it and run a Tableau report. They need that in real time. They need it to go to that system and say, you need to turn down the rubber extrusion by this click because we're wasting too much rubber. And so for them, it's understanding, where's the data coming from? What's the time frame that needs to be acted upon? And then figuring out that data movement. On the back end, that data is going back to the home office. It is going back to their HPC cluster where they can do things like do business analysis and rear-facing analytics, where they can do a weekly dashboard of, hey, here's how much rubber we saved by this process. So thinking about what's collecting your data, the time frame and the amount of data, that really helps you with architecting that solution.
And I think Valerie makes another really good point, because there's a piece that a lot of folks are going to overlook, because we can spend a bunch of time talking about the plumbing, but at the end of the day, you need budget. And in our surveys that we've seen, I think, I may be getting this wrong, but 78% of all surveyed who are actively pursuing AI believe that the returns of that are going to be measured in $10 million or more. So whether you're in the business or whether you're in IT, your gatekeeper is the office of the CFO. And that brutal but most important conversation about overrunning the budget or getting new money to drive this is an important conversation to have, because the competition is not going to wait. This COVID and pandemic is not waiting. So a critical success factor in any of these AI projects is to have a frank and honest discussion about what can we do with the money we have, how quickly can we see results, and then what do we do when we need to scale it? Because if we take the easy button and run off to the public cloud, we may have some quick wins, but all of a sudden, back to Valerie's point, we're now getting into a place where the monthly bill means that the CIO may not have his or her job in 6 months. So we oftentimes advise not only having the business conversation, the finance conversation, but to keep our eye on the future to make sure we're not putting ourselves in a compromised position 6 or 12 months down the line.
Yeah, no, that's a great point, because you're right. You're establishing a new line of value for the business. You're plugging into the business pipeline and making sure that the profits stay healthy, or the maintenance is healthy. And so Anthony, you had a really interesting analogy, because you're right. You say you don't want to spend a lot of time talking about the plumbing, but when you really look at all of the systems that support AI, you were talking a bit about an amusement park and all of the different bits and pieces that really go into making an amusement park successful. But I guess, could you sort of draw an analogy on either amusement park or something else, but it really sort of talks to the overall complexity versus what people see? So management may see a certain thing, but really there's all sorts of magic happening behind the curtain, right?
Yes. And I have not worked at the Magic Kingdom, although I have a really good friend who was in costume. And there's a lot that happens. So the guest experience is kind of like your customer experience, whether that's internal or external. And that kind of gets into, that's what we want. We want that experience to be premium, rich, and quick. But underneath that, we really have to have an eye on what is it going to take for that to make it so. At what point do we make the investments so that when the data comes in, we know exactly how to ingest it, transform it, clean it up, and then get to the result sets. And so there's a little bit of work required in order to make that happen. So AI is like the Magic Kingdom, is like Disneyland. It is full of surprises and wonderment and adventure. But making that real requires serious engineering and good planning. And that's why between CDW and Dell Technologies, we're here to help. We've done some of these projects that are very close to what a lot of our attendees are looking for, which is, how do I make this real? How do I go from concept phase to actually moving into production?
Yeah, no, absolutely. So then, Valerie, one of the challenges that I have when I look at the AI space is there's a tool for everything, and there's very niche tools, and I saw an eye chart that's just different logos that are AI software somewhere in the AI stack. So there's all these services out there. What are you seeing in those services, and are we starting to see some of those tools become a bit more across the industries, or are we seeing specialization? What are you seeing in the different types of software that's out there in the AI space?
Sure, yeah, and a lot of it is, it's an engineering answer. It depends. There are some definite off-the-shelf pieces of software. I've worked with radiology companies who, I don't know if people know this, but radiologists are miserable people. They sit in a dark room all day long and look at thousands of pictures, and there's a shortage of them. So they're leveraging AI, and sometimes with just off-the-shelf, where all that AI work has been done for them, and they're just using an off-the-shelf program to do things like identify tumors, which is awesome. And then letting their radiologists focus on the more interesting stuff, as they say. However, and there's a picture for you. I thought, as a woman, I thought that was pretty amazing that they're 92% accurate with off-the-shelf software identifying a tumor. That's awesome. I love that. For companies who are building their own, there are definitely toolkits out there. TensorFlow is a big one. You hear that one a lot. That one's a very popular one. A lot of my auto companies use it. Really, your toolkit of choice, a friend of mine in NVIDIA says, just pick something and do it. It's not important the logo. It's not important the is it TensorFlow or Cafe2. Pick something and start using it. I did want to pick on the cloud just a little bit if I could. A lot of people get started in the cloud because it's easy. You can swipe a toolkit, or swipe a credit card. They have amazing toolkits out there that are ready to use. But back to our conversations around scale of data and data gravity, and Anthony's point about the bill 6 months from now, sometimes when you go into production, it's not necessarily going to scale really well. It can get very expensive, and there's concerns about compliance, GDPR and data sovereignty, where I don't know, what data centers my data is in. So all of those things, the toolkits are very easy. Great way to get started, but scaling, it's something really you need to consider as you go forward into production.
Okay, and then I also wanted to, so I'm going to take a tangent here. So anybody who's on the call, all of our customers, obviously, if there are points that you would like us to elaborate on, we'll be doing a bit of a Q&A at the end. If you have questions, feel free to submit those. And we're happy to work with you after the call, but I just want to make sure that we're going to try and save a few minutes at the end for Anthony and Valerie to answer some questions. So just feel free to submit those. So now that I've got that out of the way, Anthony, when you look at that space and you look at all the tools out there, to me, with more of a traditional infrastructure background, that's a lot of logos out there. When you see customers sort of trying to wrap their mind around AI and all of the tooling that's involved, what do you think of that space? What do you think of those software packages that are out there and building that stack yourself? How are customers doing with that?
Well, it does require a little bit of research and understanding, but the good news is many of the algorithms or frameworks, I should say, like Cafe or TensorFlow are open source. And so you don't need a license in order to take advantage. If you've got some oomph, you've got some programming skills, you can download a lot of these things from GitHub and get started. Where a lot of the software companies come into play to try to add value in that is, how do I orchestrate the frameworks and libraries relative to building a compute cluster and connecting it up to the storage and making the network run? That's where things get interesting. Or even just, how do I do some basic transforms so that my axes go from horizontal to vertical or vertical to horizontal? I got to join this table and this table. That's where things get interesting. And there are some that are better than others, and a lot of reviews. And certainly if you want a tech advisory service, we'd be happy to supply that information, relative to your own particular situation. But at the end of the day, you could do it on the cheap. You could, if you have the time and capacity to do the learning and coding skills. But if you want to skip ahead and have a predictable outcome, have a team that you can trust, then you're more likely to work with more trusted platform providers, more trusted ISVs.
Yeah, and that's where I think both of you sort of hit on a problem earlier, and that is that a lot of times it's the data scientist that's left to do that integration and some of that coding and have a little bit of that expertise in those open source codes or those open source tools, and so I guess it's a bit of a challenge where you may be saving effort on doing the infrastructure with the IT team, but you may be loading up your data scientists with some activities that really aren't their core competency, and they may be working against what, say, IT standards are, or compliancy and things like that. So yeah, I think that's a really interesting point around you're right, you want to do it and you want to build the system and get value out of it, but you also want to make sure that you're leveraging the right people to get that done, and the high dollar amounts that data scientists make, it's probably not the best person to be troubleshooting or rewriting Python to get something to work. So
the biggest frustration for data science today, outside of having to munge the data, is a limitation on tool selection. So science, as the name implies for the data scientist, is about exploration, about having a theory and then trying to prove it against it, or at least have a postulate. What it runs counter to is engineering, who's got to make the world work. They are the bridges and roads people. So we're looking for that right intercept where the bridges and roads people, the engineers of the organization for information technology, can provide a platform on which many different tool chains can be applied. That is the sweet spot.
Yeah, and yeah, absolutely. And that's really where I was excited. So, Valerie, I don't want to spoil it, but when you talk about the Dell platform, like what does that look like?
Yeah, sure. I mean, we're all about choice. I mean, I think that's one of our core tenets is we're all about customer choice. And so, if you want to start in the cloud, we're going to support your choice. We're going to give you connectors to that. But we have a broad variety of things that we can bring to the table, depending on if you want to start small or if you want to scale large. So here's a picture of our
Sorry, I switched it on.
HPC and AI and oh, that's okay. And data analytics platform. Here is where we can start. So no matter if you want to just get started with a data science workstation, this could be something dedicated for a data scientist, or it could be a foray into a POC of AI in your environment. And you can start really small. There's a Dell Precision 7920 workstation with some unstructured storage behind it. To be able to go and support a certain number of GPUs and a certain number of images per second if you're doing image recognition, to get started and see if that's going to work for you. If you're already down that journey and would like best of breed, we certainly absolutely can support you, and we're going to propose our servers with NVIDIA GPUs, as well as possibly all flash on the back end to get very, very fast. We have reference architectures that can show you how to build your own. It's a cookbook for setting up everything all the way up into the schedulers and things like that for your AI or your HPC environment, as well as ready solutions where we can come in with consulting and put together everything. And so here's a picture, kind of an eye chart, but it's a picture of what we can bring, not just the plumbing. So the plumbing's at the bottom. We don't even really have any logos there. It's really about the things above the stack of the plumbing. So what kind of playbooks do we have for Ansible to automate these things? Cluster manager with data science portals and things like Kubernetes schedulers and Helm charts. CUDA for the NVIDIA side. So all of those things that we can put together to get your data scientists an environment where they can just go and start learning and start deploying. Whatever type of frameworks you want, we can integrate those. You can add your own. Again, Anthony said, we want to give people choice, and we want to give something where we have something that makes it easy to consume and have those data scientists get to work instead of having to build the, all the way down to the plumbing.
Yeah, that's great, and that's we didn't want to show too many visuals, and the interesting thing I find with that the platform slide with Slurm and some of the other tools that are on there, that's a bit of an eye chart. But then if you really start to put up all of the potential options, it's so the logos are so small that it's hard to even see some of them. So I guess Anthony, when you look at the Dell platform and what's available, I know we talked about the plumbing being sort of the last thing to worry about, but it really seems like Dell's platform extends into working with specific tools and helps maybe helps the engineers reach out to the data scientists a bit, and it allows the data scientists to reach back to the engineers with sort of this agreed upon set of software. How do you see that working out, and how does the Dell approach support that?
Yeah, so what's interesting, we took the premise that we need to provide freedom for the scientists and control and stability for the engineers. And, tying your shoe, as it were, it would not be a problem. But if you had to tie, let's say your arms were in a cast and you couldn't tie your own shoes, but you had to ask a neighbor to tie your shoes, well, getting that coordinated would be a very difficult and timely proposition. And that's typically what happens when a data scientist says, I'd like to spin up a cluster really quickly and be able to experiment with TensorFlow, this new edition on this epoch of information. So what we've built specifically is to take IT out of that direct path. So in other words, there is a Jupyter notebook that's a very familiar working environment for data science. And the minute they make choices on what kind of compute they need, what kind of storage they need to mount, and what kind of results they want to see, and press go, then the system gets recomposed in a way that makes sense for that particular data science. And we did this with multiple data science communities in mind, meaning that it's a multi-tenant architecture. It's not designed for just one. It's designed for the most optimal use of the spend. And the reason why that's important is because the minute you start with a workstation, and we absolutely think you should, if you start putting workstations under every desk, you're going to have some trapped or idle resources someplace else. But the minute you co-locate that into a single environment and provide remote access to this bank of computers that may be accelerated with the GPU or may not be accelerated GPU, you've got to look at the scheduling, the interface. That self-service portal is critical. So we spent a lot of time taking best-of-breed technology and then working at it from the lens of the end user back into how it should be deployed. And the screenshot, the visual architecture that we presented was meant actually for somebody who's very familiar with high-performance computing. And once those simulation jobs were done, they could turn around and redeploy that to run kind of an AI or convergent neural network. And so they can be totally separate type of things. How do I create images, and how do I distill data from those images? And it's all a matter of working the provisioning software in just the right way.
No, that's awesome. So, so we're starting to approach, the end of the hour. I want to make sure we have time for questions. Although I haven't seen any questions come through. Robert's going to send me the list of questions we had beforehand. So I just want to give each of you a couple of minutes to talk about AI, and maybe it's not something we covered, but Valerie, when you look at our customers and the challenges they have with AI and all the things we talked about today, what advice can you give our customers, to try to help them learn from maybe some of the other engagements that you've been involved with?
Yeah, sure. I think it's really funny that Anthony said, you should start under your desk. And I have worked with customers who, and they do. The problem is getting out from under the desk. And I talked to a research university who they had researchers who were literally under their desk, and they could process 6 images at a time because they couldn't get that many resources in a desktop computer. And so I think the challenge is, for them in particular, and I think probably for a lot of companies, it's IT advertising what they can do to the people who are under their desks, because they're not often being provided this gear and doing these things. They're not being provided them by IT, or maybe it was just procured for them, and maybe IT doesn't know what they're doing. But building an infrastructure where you can get people out from under their desks, you're not going to get to analytics accuracy 6 images at a time for doing image recognition. So figuring out what the needs are, building an infrastructure, and then to Anthony's point, setting it up so it's multi-use case, multi-tenant, and they can get out of it what they need to do, whether it's batch processing during the day and AI at night, or whatever they need to do. It's like the field of dreams. Build it and they will come.
Oh,
it's interesting. There are different problems at each stage of the maturity scale. In the beginning, it's all, how do I get started? What use case? Where's my data? How do I process it? As you get closer to moving to a centralized or shared services model where you have a bank of systems, it's all about multi-tenancy. How do I organize it in such a way? How do I get the cluster to work in such a way? As you get further down the maturity cycle, you start talking about scale. What's the best use of the dollar I have today in order to maximize my spend? And at each one of those stages, Dell Technologies and CDW has a qualified opinion. We'll give you, based on our experiences, a very explicit answer based on what you're trying to do, what's available, and where we think the big technology bets are.
No, that's great. And then I'm going to ask you, Anthony, to touch on something else, because I think we have a lot of customers that have done more traditional HPC, and they have Isilon deployed, or they have large data lakes or Hadoop environments, and they've gathered all of this data, and maybe they're doing high performance computing, and they're thinking about trying to get into AI. And so when you look at those, and and I know that there's a lot of slides that have them right there side by side. So what are the similarities there? And for our customers that are doing more of a traditional HPC, really, what does that change in adding AI look like? Is it completely new, or is it something that's more of a bolt-on? how do our customers approach that?
Yeah, so I'm going to answer that in a couple different layers. So layer number one is the role of high performance computing is to take processing and memory to its next logical conclusion. And in this process of doing inductive reasoning, where we have a premise and then we have certain policies or descriptions of, like, if we did this, this is how the protein would fold on a certain probability. When you take that, you are creating a kind of simulation. I mean, imagine there are no more crash test dummies because it all happens on the computer. And this is a simulation model. And you use technology referred to as high performance computing to get to that. Yeah. Now, on the other side of the spectrum, I call that big compute. On the other side of the spectrum, we experienced something called big data, which was as you were coming into your e-commerce site and clicking on certain things, this clickstream information was creating reams and reams and reams of information. And we didn't have any idea what you intended. But if we looked at the patterns the time you came in, your zip code, we could determine certain rules or policies. We call this deductive reasoning. So inductive and deductive reasoning coming together under one platform. So what does this mean? This means that, let's say, a researcher who was trying to discover what's happening in the heavens hundreds of millions of light years away may start seeing changes in the way the LiDAR is reading the light coming off of those very far away solar systems. And it's trying to determine, using that data, LiDAR, what might the objects be doing. But LiDAR is actually also used in automated driving cars. So now we're taking the same kind of practical operational technology with research technology, and a researcher doesn't care what category we call it. They just want to figure out what happened. And so this is where the place, whether you're trying to figure out the origin of diabetes, as we saw in Arizona State, they're just trying to take as what they can do and looks for parallel, covariant outcomes in the high performance simulation world, and kind of put this together under one roof. Because again, you can have it do simulations in the afternoon, but in the morning it was actually trying to figure out patterns from the simulations from the night before.
No, it's really interesting, and you're right. It's like, you've got a left brain and a right brain, and together being able to use both of those different types of analysis, there's definitely power there. So so I'm going to transition. There's some questions that were submitted before the AI session here. I don't want to belabor it too much, but I do want to let you know that here at CDW, we are working with our customers to help them, design appropriately. So, we talked about some of the plumbing, but when we look at where we're talking about compute, whether it's CPU or GPU, talking about high-speed networks and interconnections that have very, very specific requirements. We're talking about storage and the throughput that you need from storage to support these systems. These are all areas that we engage with our customers quite a bit. So we are more than happy to set up follow-up conversations. We're going to answer some of the questions that came in. If you have any additional questions, feel free to throw them into the chat or into the Q&A section. And it's great to have Anthony and Valerie here to talk about these things, and we are very excited to engage with everybody on these types of opportunities to help you sort of avoid some of the pitfalls. When I look at the questions here, Valerie, specifically with the medical image that we put up there, there's a question regarding specifically to healthcare, and I think Anthony was talking a bit about the testing with diabetes and some of the simulations there, but AI in healthcare, what's the role that Dell's playing there, and where our healthcare providers are already struggling with the amount of infrastructure they have to manage, how is Dell and maybe the Dell platform supporting easing the workload a little bit?
Yeah, sure. I mean, there's that concept of precision medicine. Can we take images that have already been done of studies and look and see if we can correlate things like outcome with of this particular image, this particular tumor type with the treatment that's been done, and then maybe target people individually with that medicine. And so in order to support that, I mean, you've got to have the data. The interesting thing is with compliance, depending upon the study that's been done, hospitals and healthcare organizations have to keep the data a certain amount of time. Could be 7 years, could be a certain amount of time past the point where they turn 18. You have to keep the data. Can we get value out of it? And so it's not only just storing the data, it's not only having it available and having it online, because if it's stuck on a tape, it's probably not going to do you a lot of good, because you can't really point an HPC cluster at a tape. So keeping data online, but then also ensuring that it's of a high enough quality and high enough performance that you can point your analytics engines at it. And so we're working with a lot of research institutions. I know I personally work with research institutions who are on the clinical side, helping them understand what are those workloads, making sure that they have the data there, it's performant enough, and that they can point their analytics engines on them. And so that's a lot of the work that we do.
And I'm going to follow up because there's another question regarding specifically Isilon. So in a lot of the work that we've done, with customers around HPC and whether it's educational institutions or whether it's healthcare, is back-ended by Isilon. And so if our customers have Isilon and they've got a bunch of data on there and they're leveraging it for HPC, how do they also get AI going? And are there certain things that are already deployed that they could take advantage of?
Well, it's funny. I wasn't going to mention product names, but thank you for doing that. So Isilon is that's my baby. That's where I live and breathe every day. And it's funny because a lot of customers have it because of the scale and because of the multi-protocol. You have the opportunity to point different applications at the same data set. Huge value. You don't have to copy data. You don't have to manage it across networks. We're also accidentally one of the best architectures for AI, just in the it's a design decision that we made as a distributed scale-out architecture 15 years ago, but we accidentally, because of those decisions, are really one of the best infrastructure, the plumbing pieces that you can have for the data, because we can keep scaling and scaling, and depending upon the number of GPUs that you throw at a problem, we can scale. I mean, we've tested 72 and beyond. We can just keep scaling that performance. So we're very uniquely suited for those type of workloads, and because we are multi-protocol, because we scale out with different node types, you could have the opportunity to have the same data, have different applications pointing on it, and I definitely do have customers doing that. Okay.
So Anthony, a two-part question. There was one of the questions that came in was, can you give a couple of examples of AI providing a tangible benefit, which we've already talked about a few, but what are your favorite couple of tangible benefits that you see in AI? Then the second part of that, is really, is there any place we can see AI in action? Like a live example of the speeds and feeds and what's going on.
Yeah, no, we have solution centers which we do demonstrate the technology. We can go down to the various sub-level components, maybe even run simulations. Bring your own data. We'll show you what it looks like on our systems. I think some of the key examples that I'll refer to in what we've seen is, let's say, for example, believe it or not, there are things called fraud in terms of warranty, people saying something's broken when it's not broken. And when we put human beings to go investigate, we saw a 4x ROI on that. But when we had AI-enabled decision-making process, that ROI went to 13x. So that's a clear example. We've also, based on our own just really simple cost avoidance of downtime, have $2.5 million worth of savings by looking at our own IT plumbing with an AI lens. And those are just a couple of examples of us internally getting healthier and more physically fit, fiscally fit. But we find that the results come down to three basic things. There's the cost savings piece, which always gets a green light. There's the fact that new customer revenue spend on average is upwards of like 16%. And some of the more interesting results is that employee decision-making is actually accelerated by 16%. In large organizations, this is a problem. How do we get to the right answer or agree on the final outcome. So the speed of decision making is one of those hidden factors that I would invite our listeners to look into further.
Okay. And then the last question we have, we're right at 3 o'clock. And I'm going to take a shot at this one. You guys can correct me if I'm wrong, but the question is, how do we coexist with machines that inherently lack human values in AI? And so I'm going to go back to my Skynet. We're not talking about Skynet. I think we're really talking about, and we're not talking about autonomous decision making. We're talking about data-enabled decision making and giving us additional data feeds that are allowing us to make good choices. So it's data either back up what we felt we should already be doing. It's trimming down the amount of data we have to go through to find the relevant data. But it's really that we are leveraging AI to make enabled decisions. So Valerie, am I on track here? Did I get that okay?
Yep, and then there's a whole nother fireside chat to talk about bias in AI. So I think that should be our next one because there can be bias based on your data sets, based on the things that we bring to the table. Computers don't inherently have bias, but we can put our biases into them. And so that's an important thing to make sure that we understand them and mitigate them.
Awesome. Well, that's the time we have. I like I said, I would love to encourage everybody that's on the call here. I believe that we're going to be posting this out to YouTube. Please share it. We want to have further conversations. We really didn't want this to be so much of a product pitch. We wanted this really to be about AI. What are the challenges our customers are facing, ways that they're getting through it. But Valerie and Anthony, thank you very much for your time. It's like I said, I always learn something from you guys, and I'm glad that there were customers on the line to learn as well.
Thanks for having us.
It was fun. Yeah, thank you.
Thank you both of you. Have a great one.